Good morning, everyone. Welcome back to our webinar series. It's hard to believe it's June already. Just some usual housekeeping. The series is sponsored by our good friends over at Site, so thank you to them. Presentations and recordings of each of the webinars, including today's, will be available later today at isa.org/webinars. And a reminder that Virtual Envirotech is just 8 days away. Next Thursday and Friday, there's 27 presentations over 2 days with 7 webinars, 14 hours of potential professional development for you. All the sessions are recorded for those that are registered, and it's only $49 for members and $79 for non-members. We would really appreciate your support. If you could register yourself, some staff, whoever, we would really appreciate it. So for today's seminar or webinar, it's sponsored by our good friends over at Trace. So Disruptive Energy Transitions with Kay Shamugam over at Gasonic, and Kay is going to speak for 30 to 40 minutes, and then we will do the usual questions and answers. So I'm going to turn it over to Kay, and Kay will take over. So Kay, you should have control.
Show my screen. Okay, are we on?
We are, and your mic sounds good. Thank you. And I'll jump in as we discussed.
Okay, good morning, everybody. This is a new thing for me. I do lunch and learn, and this week I was supposed to be at City Hall talking to about 200 kids about electric cars. So hopefully this is good, and eventually the recording, I think your kids might be interested in looking at that too. So disruptive energy transition. Let's go over it. You probably read a little bit about me, but let me tell you something else that you don't know about me. I was actually born in paradise, at least according to Mark Twain. I think it's become a marketing for our good hotels and our beaches, but I'll take it. And this is where I grew up. Clean water, clean sand, clean air, and I've never ever seen pollution in my life when I was there. So that was the great place to be brought up. But I've said that I no longer talk about climate change, and one of the reasons that is the case is this is the beach. This is where it is, by the way. It's 24 hours flying time from here. And this is what the beach looked like. 1 foot of sea going into the beach every year. So in 15 years, most of the hotels will disappear. Will not be practical to get in the front door of the hotel because the water would be right there. So that's what I don't think we can stop that. So I refrain from talking about climate change. So what about energy? Obviously, Alberta, we are the energy superpower, and energy, the sun is the source of all energy that we use. Even the oil that we use is ancient stored sun energy. So the sun is really the source of all the energy we have now. We're blessed in Alberta. We have both the stored energy, but we also have sun for solar panels and so on. So we are blessed with a lot of energy. So the energy transition has happened over millions of years. We started using sun energy for millions of years, and then in 400,000 years ago, we invented fire and had wood, and then we started using coal, and we had obviously to dig for coal in 1700, and then we had the Industrial Revolution, which was powered by steam trains and so on, and then we went on to discover oil, and essentially we started the transportation revolution. But today we are going back to the sun, and I'll show you how and why we're actually going back to using the sun more and more. So what I'm going to be talking about in the disruptive technology is three things. Solar panel. Windmill is a form of solar energy because you got a variation of energy between two places and you have the wind. And we'll talk about energy efficiency and obviously the light bulb. And we'll talk about the EV revolution, the electric vehicle revolution, and how is that going to impact us. So what are the factors that drive disruptive technologies? Well, the first one is price. I'm sure a lot of you will say, oh, I don't want to buy an electric car, it's just too expensive. And obviously it's coming down, and what is that price? So you've got a crossover price. So the price that you have for that product is below the price that you use right now. So if it's a gas car you have, once the crossover happens, you will certainly consider an electric car. But the other one that's really disruptive is when the operational costs cross over. And then once in a while you have a dark horse, something that you never thought about, which actually changes everything. So if you look at solar energy, and I've got this thing in my, sorry, I'm just, so if you look at solar energy, 1997, it was $77, so you could see the drop. 2013, it was 70 cents. That's installed per watt of energy produced. So essentially, you've seen a rapid drop in the cost of it. And if you look at the cost of solar, I've only got US data, but you can see 2010, things really started dropping. 2010, it was 52 cents for residential, obviously less for commercial and less for utility scale. But as you can see, 2020, we are really now under 10 cents, 8 cents, and so on. So you're really getting a push now for energy using solar panel. So here's the crossover price. So 2013, solar crossover nuclear and coal. So you haven't heard in Alberta us building any coal-fired plant now since probably 2010 or something. So, and we cross over natural gas, which there was a lot of plants being converted to natural gas for a while. And then we cross over that in 2015, 2016. And essentially, it takes a little while for that to work throughout the system. But within 2 or 3 years of this crossover price, you suddenly find it was not, you don't want to build a plant that the cost of a solar plant is actually less than a gas or coal. So this is what exactly happened. The two projects in Alberta, 2017, so it was better to build a solar plant, and it was a 17 megawatt at 4.8 cents per kilowatt. In 2020, they're just building that right now. I don't know what the price is, but I would expect it's under 5 cents. A 500 megawatt, that's like a million solar panel. It would be close to Vulcan, and it's incredible, the size of it and the amount. It's going to probably run about 100,000 homes, and this should be done within the next couple of years. So we see the crossover point made it very, very effective and very cost efficient to build a plant. Now you may ask, what about energy storage? Because solar energy cannot be used without some storage. What is happening to storage? Batteries are expensive, you may say. And here is, this is Nevada, so it's not Alberta yet, but it's 2.3 cents per kilowatt, including storage. I don't think we'll get that in Alberta at that price, but it's coming. It's coming down in 2 to 3 years from now. I think storage will be cheap enough to to be under 5 cents for sure. So it's incredible changes in energy mix. Now, operational crossover is very interesting. So you have solar energy that's obviously been dropping. You've got coal plants with regulations and other costs, it's been going up. So in 2020, we're supposed to cross over that point at which it's more expensive to keep your plant running than to close it and put solar. And wind has been going down as well, but solar now is going lower than wind because it's a lot easier to put solar panels than it is to put windmill up. So we'll see a big change in that. Solar, I think, would be the number one. And we can see in the US 2019, new wind solar cheaper than operating costs of existing coal plants. So we're really there already in the US, and we should be like that in Canada within a couple of years. So now we've dealt with solar, let's look at energy efficiency. I believe that the light bulb, which obviously it's used around the world, almost everybody in the world has electricity. Maybe 1 billion people don't have delivered electricity, but now they can put solar panel and have electricity. And the light bulb can really change the world. So this has even been very, very dramatic. So you could see at 2010, it was $80 for a bulb, and today it's under $5. I think you can pick them at Costco for $2 or $3. And the life expectancy is being the drastic change. I remember having an LED bulb that I hardly last about 3 months, and now it's 50,000 hours. So that's well over 6 years, 7 years. And even that, I think it will supersede that probably by another 3 or 4 years. So that's the curve that's encouraged that. This, by the way, it's a non-linear curves. So you could see it's just like the virus, COVID-19, it grows very, very rapidly. But the lumen per lamp, which is the brightness of the light per lamp, is really been accelerating since we introduced the LED in 1970. And actually, I worked in LED when I was at university in the 1980s, and they've got very, very bright. But the difference is when we started use it for light, we needed to develop a white LED, and the cost has just gone down tremendously. So the price crossover for new project is almost there now for most places. This building in Amsterdam went one step further. Instead of putting their lights onto the 120 volt supply, they actually put in low voltage lights. So they run low voltage, put LED lights, and they had a bonus. I don't know whether any of you know that, but there's something called Wi-Fi. You can actually send your internet via the light, and it pulsates very, very rapidly. You can't see it with your eye, but your phone or your device can see that, and it's 10 times faster than Wi-Fi. And the other advantage is once you're away from the building, there's no leakage. So for security reason, if you have a bank or if you have a building, you don't want the Wi-Fi to be picked up outside, then Wi-Fi is a great asset, and they got that as a bonus. So they basically wire the lights with the internet at the same time. Now I got into replacing light bulbs, fluorescent light bulbs, mostly two because my business is in Parkade, so I thought I'll try to pay for my gas detector by replacing some of them. So I just got a question. So the energy saved from about 2,000 4-foot bulbs that we replaced between 2014 and 2018. And I'll tell you a little bit later why we stopped in 2014. So how far would an EV travel? I've got a Tesla. If I take that save energy, which is direct electricity, to electricity in my car. And I've got 3 questions for you. You can write that down, 1, 2, 3. And I guess it's sending it to Joel. I don't
Yeah,
see
you can type in your question box answers to the questions, and we'll see what everyone says, and then Kay will give us the answers later.
Yeah. So around the world, 40,000 kilometers. On the moon right now, if I drove my Tesla right into the sky, obviously it's just imaginary. Or have I passed the moon? Maybe I'm onto another planet somewhere. So I'll give another 10 seconds, I guess, to just people to put an answer. It's a fun answer, so don't think too hard on it. And here is, imagine my car is driving on this road, and I actually did the calculation. I said, let's see whether we can go around the world maybe 10 times. And I looked at that and I said, no. We can go to the moon. And I Googled the distance, of course, and I found, no, I'm really past the moon. And it was 13.9 million kilometers. And I'm about 1/3 of the way to Mars. Mars is not a fixed distance from Earth, so it depends when you talk about going to Mars. But 13.9 million kilometers is a lot of energy. So this tells you the power of saving. We very often think, how do we produce energy? But the energy it takes to produce energy is really, really difficult and expensive. Saving energy is incredibly inexpensive. You get your money back. And so, it really helps out to power the cars, I think. So that's the surprising answer. I hope some of you got it. But so what I did after that is I set up a company, and that's why I stopped doing retrofit for a while. I set up a company because people was asking me, what do you do with a fluorescent light bulb? And I started a company that actually recycled fluorescent light bulbs, and we sent it to Winnipeg. Behind the wall that you see here, my people right now is loading 27 of these skids to go to Winnipeg to get recycled properly with zero waste. So that's how I got a little bit more passionate about this than actually on changing lights. But something else was happening as well. There was a technological change that was coming. And this created what I call the crossover, the operational crossover. So something called plug and play came in, especially for tubes. I mean, we're talking to a lot of businesses. Our customers are businesses in parkades, and you can imagine the number of lights in a parkade. You could have 100 bulbs, 200 bulbs. And so you couldn't get an electrician to change everything, which we had to do initially. You actually now can plug in a T8 and take away the fluorescent light bulbs, and you're saving right away about 40% of the energy. You can't do that on everything, but for most of it, you can do that. And now it's dropped from $100 to $20. So your payback now is within 1 year. So this is going to make the big change. And I've been to places in the world that they're doing that in a huge way. The Chinese, obviously, in China, they're changing cities completely with this. And even back on my island of Mauritius, a lot of people are changing the tube to LED in offices. So that makes quite a difference. And that's going to be a rapid change. And here's all the energy. And my concern is really, can we power all these electric cars? And if you look at one of these lights would power an electric car for 500 kilometers a year. So you get your money back in a year, and you can transfer the energy to an electric car and run 500 kilometers. I think it's a good deal. What's the dark horse of light retrofit? What is something that we never thought about that might influence the fact that we'll do more retrofit and save more energy. It's amazing what it is. It's clean water, actually. What's happened is they discovered that, and there's a question for you. You can write the answer down. How much water can one of these light bulbs, I'll assume these light bulbs are 4 foot, and a lot of you guys may see that in mechanical room with people not knowing what to do with them. And when I learned of this answer, I was so shocked that I said, you know, we've got to do something about it. But how much water can be contaminated by mercury from one of these tubes? Is it 5 liters, 50 liters, 500 liters, or 5,000 liters? So I give you a few seconds to write the answer. Again, it's just fun, so.
Getting lots of 4s, lots of 5,000 liters.
Okay, we've got people that know their stuff, I think. Yeah, the answer is 5,000 liters. So it's amazing when you think about it. We probably sending 10,000 tubes today, and if you had these tubes contaminated the water, we're talking about the millions and millions of liters of water would be contaminated. So one of the dark horse is the fact that today we have a law that says you cannot really put light bulbs in the landfill. And I know many of them end up in the landfill. I've gone to the city of Calgary, I've talked to them, and most of the light bulbs end up in the landfill. It's a federal government, and obviously we have jurisdiction issues where it's going to take 3 years for them to do something about it. With COVID-19, I think everything is delayed. The city of Calgary was going to put a bid out, and they've asked us to bid on this to do the city of Calgary, but I think now it's really delayed, or it may not happen because there's other priorities. So, but there's a law. Eventually, we will not be able to put fluorescent light bulbs in the landfill. And if that's going to happen, I think it's far easier to buy LEDs and replace all the light bulbs than trying to figure out where to get them recycled. So that's what is happening. That's the dark horse. I think it will push the retrofitting very, very fast. Now, my favorite subject, the coming disruptive EV revolution. What is happening? A lot of you have either been in an EV, maybe you own an EV, and I'm sure if I ask you the question, will you ever go back to an ordinary car? Your answer will be, I will never go back to a gas car. So the internal combustion engine has a lot of parts, 2,000 parts. And if you look at the internal combustion engine, it's still about fire. We haven't reinvented fire. We haven't reinvented something else to really change the technology. We still, in a way, it's a sophisticated steam engine, maybe a lot more sophisticated, but not very, very different. But an electric car has only 18 moving parts. So you can see the disruption that would happen, the logistics of that. If you go out east, obviously we make a lot of parts and it crosses the border back and forth, and so on until you finish building the car. This is expensive logistics and a lot of travel. But if you have 18 moving parts, it's very, very easy to make. You can have one plant that makes everything. So here's another question for you. What percentage of the energy used to move the driver in a gasoline car, just the driver? So is it less than 1%? About 10%, between 10% and 20%. When I had this slide presented to me, it actually shocked me that I actually changed my whole perspective, because really what I thought of is, here we are, the driver has the power, and if more and more people make that change, it cannot be stopped because there's so many of us. And if we all make a little change, maybe walk, maybe take a bike or whatever, the changes to the supply would be incredible. So, okay, hopefully you've got the answer down. Let's go for it now and see what really happens. So here's the car, and here is the energy loss. 62.4 on the engine, 17.2 on idling, 5.6 driveline losses, 2.2 accessories, 12% moving the car itself. And I was shocked by that answer. The answer is less than 1%, 0.6% moving the driver. So when I saw this, I looked at it and I said, let's reverse that equation. We have the power, we can decide what we do, and therefore anybody in the world has that power of deciding what they do, whether they drive a car or not. And an electric car, essentially, let's look at the same thing, but put some figures, estimate of exactly how much energy is used. So we don't have any idling in an electric car. You stop at a light, the engine turns off. There's no energy leak. There's a slight energy leak if you're putting your accessories on and you're putting, you know, your air conditioning on, but certainly not as much as a gasoline car. The engine losses, let's assume it's half of that. I know it's at least 50% more efficient. That's what Elon Musk says, but let's put that and see what happens. It's 48.4%. So that's incredible when you think about it. The driver has the power to not use a car or use an electric car and save tremendous amount of energy. Now, battery costs, that's what determines the car costs. The battery cost is about 1/3 of the whole of the car manufacturing cost. So it's got a real effect on the price of the car. So in 2010, we were $1,000 per kilowatt hour of electricity from a car. Today, or we're coming very, very close to it, we're going to go under $100. And usually that happens right now, they say 2023 or something on this one, but it's actually, I think it might be sooner. It might be 2021 or even we're very close now. So that's incredible when you think about it. It's going to slow down. It's not going to keep dropping at that rate. But you can see once it's $100, that makes a huge difference in the uptake of electric vehicles. And you'll see the price. Tesla just announced last Monday that they're dropping the price on every single car. My car is dropped by $7,000. So good news on that. And what we're seeing too is the saving in fuel and maintenance. So just talking to Joe earlier, saying that I hardly have any repairs in my car. I just put windshield washer and off I go. And the cost of driving it is dropped. And you could see in Saskatchewan, it's 65% lower to drive an electric car than it is to drive a gas car. And in Alberta, it's 72%. And it's going down, and they say if it's 90%, it's over. So that's dropping tremendously as well. Now, how would you know about operational crossover? You know, you're saying, okay, when is that point? Well, I'll give you kind of a little story. If you have a kid ready to drive and you say, son or daughter, I'll give you the keys to my 3-year-old BMW. And the kid turns on back to you and say, Dad, I don't want your car. It costs too much money to run. Please give me an electric car, even a used electric car, I'll take it. You'll know then your car is worth not very much, that your kid doesn't want it because he doesn't want to put gasoline in it, And so you'll know that we'll cross over that. And that's why I've changed all my fleets so that I don't end up with an expensive gasoline car when that happens. Now let's look at the oil itself and the way it runs through the system. Obviously here we produce oil, so almost everybody knows that. But you can see the energy that it takes to explore for oil, produce oil, and every step of the way we have either political action, political, we have people objecting to that. Obviously, pipeline is a big one. But once we get that done, we still have to ship it, we have to store it. And today we have to store a lot of oil because we can't sell them, and we have to refine them and so on, and then gets to the gas station. And we can be sustainable. I mean, Alberta talk about sustainable oil, and there's some truth to that. This is in Alberta where you could put solar panel and actually drive a pump jack and don't use any electricity from anywhere, produce it. This, I think, is near Brooks, and so Imagina was the company run by a lady that passed away, unfortunately, a couple of years ago, and said we could produce oil more sustainably using solar panel. But this is the issue we face with. This is 17 solar panel on the roof just above me here. And if I take that energy, put it in my car, how far can I go? And can I produce my own energy and drive my car and have the lower costs? Well, it turned out to be 50,000 kilometers. So I can actually not only drive one electric car, but I can drive 3 electric cars with that. And so that's a change. And remember, this is something that could be done anywhere in the world. It doesn't have to be something that us Canadians think about. Anybody in the world with the cost of solar panel dropping, with the cost of electric cars dropping, somebody in a remote island can now put solar panel on the roof and connect to their car, use it as energy storage, or drive it. From the island I come from, Mauritius, we're 60 miles by 30 miles across. So we can easily use a very basic electric car to get around, and solar panel will do that, no problem. Most people drive about 5-10 kilometers a day. So this is a paradigm shift. This is something that can change rapidly because people have the power to do that all over the world. What is the dark horse of EV adoption? What is what we never thought about that might influence that? And one of the clues I'll give you, it's part of what we've seen with COVID-19. Everybody's talking about this. Everybody's talking about all over the world how the air quality has improved. Will that go back to normal? Will that change? I'm not sure. But I think there'll be some changes. And so clean air, as I call it, is going to be the driving force. Is it happening? Well, I was in London in 2019. I was traveling by tube, and I saw this sign that says you cannot go into the city unless you have a hybrid car, an electric car. Otherwise, you pay $20 to get to the city of London. And I saw this little article, Let's Clear the Air, in London, and it was the pollution that was affecting people. London has 9,000 people die of air pollution a year. And so that is going to be a driving force. And the mayor has health problems related to pollution. He has asthma, so he's really pushing this. He's trying to reduce the pollution. So the mayor of London has announced that 50,000 EV chargers by 2025. I was able to take this electric taxi. I was able to go and take this electric buses, talk to the driver. He was so happy he got an electric bus. The guy in the electric taxi was so excited. The only thing he had trouble was the range. So within 5 to 10 years, you'll see London have a lot of electrified transportation. They already have the underground that's electric, but now you'll have the buses, you'll have the bicycle. Incredible the number of bicycle electric bikes on the streets of London. I was so shocked about that. So we have disruptive technology. We've never introduced a technology that hasn't gone for this curve, very similar to the virus. It starts up slowly and then rises very fast. And as we go in time to the cell phone, everybody can remember the cell phone. The smartphone took, less than 2 or 3 years to really catch up. So every technology we have goes rapidly once it's adopted. And I think electric cars would be a little bit slower, but 20 years would be a long time for electric cars. I think we'll see major changes by 2030, just because all the other technologies that ever been introduced has followed this curve. So there's a question for you. I mean, obviously there's the technology that changes things, there's the price that changes things, there's the crossover I've talked about, but they did an experiment in California to see what people's attitude was on energy efficiency and so on. So there's 3 questions here. They put doorknob advertising, and ask people, would you change your behavior based on money? Would you change your behavior because of the environment? Would you change your behavior because of energy efficiency? You just want to be more efficient? Or is it none of the above? So I'll give you 10 seconds or so. I am coming close. A couple of minutes, that's not too bad. So 1, 2,
We have either 1 or 4.
3 or 4. Okay.
Well, number 1 or number 4.
1 or 4. Okay. Well, a lot of people are smart here on this one. What is the factor, and I found that, is what your neighbor does. So you don't make any changes. If you see your neighbor buy an electric car, you will be more likely buying an electric car. That's why you see this jump. In fact, I did a lunch and learn from one of my customers once, and they asked me about my electric car. And I say, I'll give you 1 sentence. It's the best car ever made for winter and summer. And the next time I see one of my customers, he was there at Tesla, bought a car. And he was just a building operator, so he wasn't the CEO of the company or anything. So he said, I heard what you said. I went and tried it. I would never go back. So it's really your neighbors. And I talked to a lot of people that have electric cars for the Electric Vehicle Association of Alberta and the Tesla Club. And a lot of them have driven into their driveway. The neighbor comes over and say, what have you got? They go on the internet and order a car the same night. So that's what's going to push it. It's that a car is something that everybody sees, your neighbor, your kids goes to school. And I met somebody in Florida last year, and I said, why are you wearing Tesla, and why did you buy a car? And the dad says, it was my son who says I have to buy an electric car. So that's a driving force. And I know from teaching kids, I've taught 500 kids, and I did a poll with the kids. I've only heard of 1 kid that will buy a gasoline car. So that's what's coming. So you can see the graph is starting to accelerate everywhere in the world. China is the #1 on electric vehicles, but it's Norway is probably the highest per capita electric vehicle ownership. So you'll see it go up, the graph going up exponentially. And so Canada even is doing the same thing. BC right now is 10% electric cars. So it almost have a double effect. So you have 1% today, next year you have 2%, and then you have 4%, and then suddenly you find, oh, we are 10% before you realize it. and then you're 20%. So this is how things grow exponentially. Of course, we all know that now with the virus, so we understand that. And so it's something that we cannot really stop. If we stop it in Canada or North America in general, it will take over around the world. So there's another thing that's going to really disrupt the automotive business, the whole supply chain, the whole ownership of electric car, and it's called TaaS. And I'm going to play this little video. It's a bit of a fun video, but let's assume you're at work, and instead of your wife picking you up in a car, you have this. So press and hand summon, and it says, "Come to me." So I'm going to press and hold that. And now we can look at the car. Oh, who's driving the car? That's the dog Jasper. So this is what's coming. This was just over the parking lot at Crossline Mills, but pretty soon you'll be able to call your car right from home and go and pick you up and drop your wife over and so on. Anyway, that's my presentation. So I guess we're gonna go over questions.
Thanks, Kay. Really interesting. Lots of information. We just last week did all our ceiling lights in our house were converted to LED, including our fluorescents. So
okay,
notice the difference already. And I have solar panels on my house, so it'll be interesting to see what happens. I recently read that if and I don't know if you can answer this, but that if 10% of the U.S. fleet was to switch tomorrow to electric vehicles, the grid and the power grid in the States would have problems. Do you know anything about that or heard anything about that?
Yes, we have to plan for that. But luckily, I'm actually working with a young guy from Calgary, and he's looked at that problem, and it's a Canadian technology, and we should be promoting that. I'm obviously helping him. But what he's essentially said is, if you have an electric car inside your house, obviously, if you plug it in and you say, okay, charge my car just the same as you charge your phone, and everybody does that in the neighborhood, you're going to have problems. Even in a building, let's say a condo, you cannot put a charger for everybody in theory. But what Unipower has developed is a smart charging system. So what they do is they monitor the whole electricity throughout the building, and they actually reduce the amount of energy that goes into the car so that you extend the charging. And they could do that for a building and have 10 times more chargers than you would normally have. And remember, you got 8 hours when the guy parks and goes to sleep in a building. You got 8 hours to charge his car. You don't have to instantaneously charge it. So by managing the electricity, you're able to do that. But the other thing I think we should be doing is remember that we save energy. Every parkade in Canada could change the light bulb to LED and power 2 or 3 cars easily. So it has to be, a planned thing that we do, but the technology is there that we can achieve that.
Yeah, someone mentioned on the comments that their company installed the lights in the parkade and then also instead installed motion sensors for additional savings.
Yeah.
So,
yeah, that can be done.
Okay, questions. Can you drive a Tesla from Calgary to Banff and back without a refill?
I can get to Banff and back without a refill. It depends what kind of battery you have, but if you have, I have 80 kilowatts. If you have 100 kilowatts, you've got 500 kilometers, and you could do that. Of course, keep your speed at a reasonable level. Mm-hmm. Typically, I go to Vancouver and I charge a couple of times. Now, in theory, right today, I can take my car and drive to Miami, Florida, or I can drive to Toronto. I have to stop and charge at the supercharger, but it's doable. Just add a little bit of time to your journey. If you plan it properly, you have lunch or breakfast or whatever, you should be fine.
Yeah, because the Tesla tells you where the next charging station is, right?
Yeah, you just plan your trip and it tells you where to stop, how long you have to stop. I think the only thing we have to be obviously conscious about, I would not be driving minus 40. Just the fact that the battery would lose capacity and so on.
Right.
I mean, you can do it, but I would prefer, obviously if you go south of Miami, you should have no problem. If you go
Yeah.
across.
What about the issue with spent batteries from e-vehicles? How long does the battery last?
Well, one of the surprising thing that we'll probably see that I predict is I've been driving hybrid vehicles since 2003, and I've looked at other people that's driven electric vehicles, hybrid vehicles. The battery in those vehicles was lasting 1 million kilometers. So I expect that they tell us the battery would last, 200, 300, 400,000 kilometers. I think it's going to be much more than that. And especially that it doesn't just drop like this. I have a Nissan Leaf that after 4 years, it actually hasn't lost more than 2 or 3%.
Hmm.
So I don't expect. We'll be pleasantly surprised about batteries, I think, because they manage properly. You don't overcharge them. There's a lot of battery management involved to make it last a long time. And the question of spent batteries, yes, I get this question a lot. I think you can take your used batteries, sell it to a building that could use it for energy storage. You can sell it to companies that would start using it as energy storage. Because once you have it as energy storage, you're not worried about taking the battery anywhere. So even if it was 50%, at least you got some cheap batteries to
Right. Yeah,
have.
and if you're getting 1 million kilometers, you're still farther ahead than gasoline car.
Yeah.
I'm going to play devil's advocate here. There's a couple comments.
Yeah.
One from a fellow person that has solar panels on their house. So you still need fossil fuels to manufacture the solar panels. You still need to mine the quartz and mine, the chemicals that we use for the batteries and stuff like that. What about the life cycle of the carbon footprint on solar panels?
Yeah, I mean, I've seen that question a lot. I think the answer is actually not electric cars. I don't think electric cars is going to solve a lot of our problems. We're right in saying that, there's batteries, there's solar panel to be manufactured, but I think it does two things that I think is very important.
Mm-hmm.
I think pollution is a major problem for us, and if we could remove pollution from the tailpipe, we could have clean air in our garages, in our parkades, and so on. I think that would be my focus. And really speaking, what I think would solve the problem is for us to use more bicycle and public transportation. Anyways, in Europe, they're turning a lot to electric bicycle, which now you have a smaller carbon footprint to manufacture that, and that's going to be partially the solution. So yes, you're right. It's not going to be the solution, just manufacturing something else. I think we've got to review exactly what we consume and how many things we buy.
Yeah. Couple more questions on the Teslas, and then we'll go. I got a question on lights. Extreme cold. How's the battery do?
Yeah, in extreme cold, you can be as low as 50% at times.
Okay.
So one suggestion I have a Nissan Leaf that had 120 kilometers, and I couldn't use it in winter. So I converted it, like I was telling you earlier, I converted it to an air monitoring unit. So I put it in a parkade and it monitors the air because I've got no use for it. Tesla is a lot better because you're starting with 400 kilometers or 500 kilometers range. So 250 is not bad. You can at least go around the city. But low temperature is a problem. We don't get that very often. Now you can warm up the car as well as you can warm up a gasoline car. You can actually warm it before you get into the car. So I see a real advantage on that. The car is very stable to drive, especially if you have a four-wheel drive. So you've got some real advantages, and if you can get away with the fact that you have lower capacity in the winter. Of course, if you were driving all the time to remote areas, I don't suggest you have an electric car right now, but between Edmonton and Calgary, you would have no problem. A supercharger at Crosshine Mills, supercharger in Red Deer, supercharger south of Edmonton, you can plug in and you're back in business within 10-15 minutes.
And I heard in California, Tesla's experimenting with kind of like a drive-in service station where a robot would drop your battery out, plop in a charged one, and on you would go. And quicker than you could get a coffee. So, and they would just keep recharging, and it's something they're experimenting with. So they're always trying and looking at things. Okay, lights. LEDs. How do you recover and recycle the mercury in the bulbs?
Well, there's a plant in Winnipeg. We're not doing it here because the plant is very expensive, but I went and see the plant in Winnipeg, and they actually crushed the bulb. But once you crush it, you have to have a system inside to suck the mercury. And there's a video on my website somewhere in the EnviroLight that shows you that process. But I was amazed that the glass was recovered and cleaned, the mercury was recovered and reused, the phosphor was done, and the metal piece was done. So I was so impressed with it. I came back, and it's a company that I run as a social enterprise. It doesn't make money. The actual shipping containers is in my yard behind this wall here, and I do it at home so that I could bring the cost down. But I have the process is correct, and we're provided a certificate that is true zero emission, zero weight on that product. And by the way, COVID-19, we didn't throw anything in the landfill like a lot of municipalities had to do. We stored them, and they all going.
Do you know how much energy they spend on the process of recycling a tube, or?
I don't know exactly per tube, but there is essentially a crusher and some exhaust fans and so on that they have. It's not a lot. I've been to the plant. It's a normal warehouse with one machine really. So it's not a lot.
Right. Okay, I'm going to do two more questions. Since you mentioned the UK, most of the UK's electricity is produced by burning fossil fuels, mainly natural gas, 42% in 2016, and coal, 9% in 2016. Has this started to change?
Yeah, I mean, the UK is changing rapidly. I visit the UK very often, and I was surprised driving in the train and going how many solar panel was on roof, being installed on roof around, not so much London, but outside London. So it's changing rapidly. The thing about solar panel is because people make decision individually, it can certainly grow very rapidly. And it's not going to be the total solution, but the grid, whether it's in Alberta or all over the world, will get cleaner from year to year.
Yeah, I noticed last year we were in London this time last year out in the countryside, large amounts of solar farms being installed and a lot of offshore wind too. So
yeah.
Is there a talk of standardizing charging station hookups? I have a photoelectric vehicle but can't use a Tesla charger, someone says.
Yeah, so there's adapters. Obviously now with Tesla trying to corner the market in some ways, they went to their own chargers. Now with any other chargers, the Chatmo chargers and so on, you have an adapter that you can go in with a Tesla and convert it. You can't convert the other way, unfortunately, but there is adapters available that allows you to charge between chargers. I'm not sure that Tesla would, the Tesla could be charged on other chargers. I'm not sure they've opened it up for the Tesla chargers to be open to other. That's why Tesla is the #1 seller, because the charging is incredibly simple and it's available almost everywhere. There's about 1,000 chargers in North America now.
Okay.
But,
Yeah, someone had a comment and a question with it, and then we'll leave it at that. Solar farms are ugly depending how you look at them, and they can destroy the ecosystem where they're built. There are impacts to that. Why is there no push to make all structures and buildings solar ready?
the long process with this building code. We deal with the building code on our stuff, and the gas detection, it takes years and years to make the changes. So that's very difficult as far as making changes there. But most houses, even my commercial building that I have where my office is, we considered solar panel, and we could fill up the roof with solar panel. So it is possible to put them on a lot of building. I wish we would put them more on buildings, because the roof is not used for anything else than solar farms. But if you go to Nevada or something in the desert, there's no problem there. I mean, you could put as much solar panel as you want. It's legitimate in the sense that it does take a lot of footprint, and the cost of that land is important. If you go in the desert, the cost is nothing. If you come to Alberta and you've got agricultural land, it's really expensive to put solar farms. But they're doing it.
Yeah, I agree that we should. Any new building or warehouse or any of these things that they're building should be made so they're solar ready. It seems to make sense that you got all that rooftop space that you should have them solar ready. It just, and I don't think petroleum will ever go away. We still need it. It has its role in products and heating and stuff like that in the dead of winter when your solar panels are covered with snow. So that'll never go away, but we need the alternatives as well. So
yeah, and my motivation now is really about the fact that I'd like to see clean air. I was teaching.
As long as I've known you, Kay, I've known you probably 20 years, and you've always, from parquet air to everything, you've always talked about clean air, and I think that's very noble, and I think that's a lot of people die around the world from lung disease and stuff like that related to dirty air, whether it's coal or oil or just whatever other else is in the air, right? So
and what we're doing right now after COVID-19, obviously, is we actually going to monitor the air quality in parkades. Obviously in Calgary, not so much in Edmonton, but we're going to bring our Nissan Leaf for free. We'll monitor the air quality, provide the person with a report as part of our research of what truly is the air quality inside of a parkade. We don't pay attention. We go and park our cars, and so we're gonna start finding that out, and we're gonna provide a piece of equipment for a technician, and that equipment will be connected via cellular network to the office, so we can monitor what kind of gases our guys are being exposed to, and we'll provide that to buildings as well. So our focus is really clean air everywhere, and that's why I drive an electric car. I will never get behind you with a big exhaust pipe. If you're in front of me, I'm going to stay away from you. If I'm on the highway, I'm going to take off and be in clean air. That's what I've been doing for a number of years now.
Okay. Thanks again, Kay. Thanks for doing this. Really appreciate the information. Hopefully everyone else did as well. Thanks to Site for sponsoring our webinar series, and thanks to Trace for sponsoring today. Reminder that once it takes a while for the video to get processed, but it'll be up later today at isa.org/webinars, and Kay is going to send me a copy of his presentation. We'll post that as well as a PDF, and a reminder to, if you have the time and want to support ISA, help spread the word that EnviroTech's next week. just a couple days. There's 27 presentations, and we've kept it intentionally very low price. So please check it out and register. We'd appreciate it. So once again, thank you, everyone. We have a couple webinars next week. We're winding down our series. It ends, I think we have 4 more left, and then we're going to take a break over the summer and be back in the fall. So thank you, everyone, and stay safe.
Thanks, Joe, and thanks everybody for attending. Pretty happy. Obviously, I don't get the response, but hopefully everybody enjoy it.
Lots of great comments. Thank you.
Okay, great.